Hello, everyone. Today, I'm going to present my research, which is to use perfluorobutane PSNE to facilitate ultrasound ablation. And I envision it as a transcranial ablation platform with improved lesion localization and tumor ablation efficiency. So we are familiar with high-intensity focused ultrasound non-invasive neurosurgery. Essentially, we have ultrasound transducer to transmit the ultrasound energy across the skull and focus the energy on the center so that we can damage the tissue thermally. And if we try to target something that is deep in the brain, we have a large window on the skull allowing ultrasound to go through, which means the average intensity on the skull is quite low in this case scenario. However, if we try to target something that is closer to the skull, we have a smaller window allowing ultrasound to go through, so it means that we might generate some unwanted damage on the surface. And previously, our lab has observed that there is bone marrow damage because of this thermal heating on the surface in some patients. And the fundamental reason behind this was that the power required to generate damage in the brain was quite high with thermal ablation. So our idea is to use microbubbles to facilitate the ablation so that we can greatly reduce the power. We'll introduce the microbubbles intravenously and we will targetedly activate them in the center. However, the challenge is there's microbubbles circulating every place in the brain that we might generate some damage in the prefocal region along the beam path where there's some bubble circulating. And our ideas now is to design this perfluorobutane PSNE, which is a precursor of microbubbles. So once activated, converted from droplets into microbubble, it can enhance the ablations. And before activation, is pretty much transparent to ultrasound so that we can prevent the prefocal damage in the prefocal regions and only activate them in the focal region using ultrasound. To test this hypothesis, our main thing we want to test is whether perfluorobutane PSNE can improve the lesion localization and also prevent the prefocal damage. You can see here, we use an ultrasound setup that localizes ultrasound energy in the rat brain. And in terms of the sonications, we increase the pressure gradually from a low pressure level and increase to a high pressure level, and then repeat it with and without each of the contrast agent so that we can determine what is the inertial cavitation threshold for each of the agents. And we fix the pressure for 2-minute sonications to see and accumulate enough sonication dose to see the damage. For each of the agents, we test 2 exposure levels, one with 5% above the IC threshold we determine using this run pressure process, and 30% above the IC threshold for each of the agents. So here's the result. You can see on the left, we essentially take MRI image from both the center and also the prefocal region, which is in the cortex. And with microbubbles, you see damage both in focal and cortex region, which is indicated by this dark spot in the brain. With perfluorobutane PSNE, however, you only see damage in the focal regions, nicely confining here, and prevent the prefocal damage in the cortex. So this suggested that perfluorobutane PSNE can indeed improve the lesion localization and prevent the prefocal damage. And also, it generates much smaller lesion compared with microbubbles, as you can see in this bar chart. And we also did HIFU staining and also confirm our finding with perfluorobutane PSNE would generate no damage in the cortex regions, and with microbubbles, we did generate some damage in the cortex regions. And after we successfully demonstrate the improvement of localization using these agents, the next question is whether it can also be effective against tumors. We implanted tumor in the brain and sonicated the brain at day 8 and took the MRI image before and after the experiments and wait for 2 days to sacrifice the animal and take the histology. So you can see here, we use the same ultrasound setup. So I'm gonna skip this slides. And you can see here on the left with MRI image, you can see there's tumor in the center of the brain. And after the sonications for microbubbles, there's ring of damage around the tumor core. And with perfluorobutane PSNE, however, would generate damage that cover the whole tumor volume. And this suggested that perfluorobutane PSNE is really effective against tumor because it covers the whole tumor volume instead of just the periphery. And you can see also on the right that HIFU staining also confirmed this finding. Last thing we did, the statistic showing that it's more efficient using the perfluorobutane PSNE. And lastly, we did a survival experiment which also show that with profobutin PSNE-facilitated ablation, we indeed suppress the tumor growth. At the same time, the suppression of tumor growth translates into improvement of survival, as you can see on the right. And that's all my presentation, and thank you for listening.